Hello everyone, welcome, Mr. Howell here. You've made it, end of the year. So 11.8 is the chain rule, okay? Our last rule for finding the derivative, okay? So the idea with the chain rule is we are going to have two functions here, and we're gonna have one times the other. Okay, and so the idea here in words is we're going to take the derivative of the outer function, right? So f prime, and then times the inner function, and that inner function doesn't change at all for the first one, times the derivative of the inner function, okay? So derivative of the outer evaluated at the inner, okay? So don't change the inner one at the very beginning, times the derivative of the outer, or sorry, times the derivative of the inner function. Holy smokes. Okay, so this one, the first one says expand y, then find the derivative by using the power rule. So if you watched my video on, what was it, 11.6, I believe, I had mentioned any of these four rules, if you can figure out how they work and kind of manipulate them individually, that's totally fine, okay? So unless we say, like on B here, use the chain rule. If I just say find the derivative, do whatever is easiest for you, okay? So the first one says expand. So we've got 3 and then 5x minus 4, 5x minus 4. And we'll expand that out. So 3, we've got what, 25x squared. Since these are the same, you guys are smarty pants, so that would be what, negative 20. So double that, so negative 40x plus 16. And then finally multiply that 3 in, so 75x squared minus 120x plus 48. So all we did is expand there, and so now to take the derivative, at least with the power rule, we'll bring that power down, so 150x minus 120. And that's it. Cool. Okay, so now on what we're going to do for this next one is we take the derivative of the outside stuff. Okay, so what that means is we kind of look at this as somewhat of, let's see if this makes sense, so 3x squared, right? So how would we take the derivative of that? Well, we would bring that down, multiply it, and that would be 6, and we'd subtract 1 from it, okay? Well, we're going to do the same exact thing, but this time instead of an x, I have a binomial. But we treat it exactly the same. So bring the 2 down, so we have 6, and then keep the inside exactly as is. Minus 1 from the exponent, so now it's just a 1. And then it says times the derivative of the inside. Well, the derivative of the inside of the parentheses is just 5. Cool. And so you could do any way you want. This would be 30. So if I multiply those two, so 35x minus 4. And so again, our derivative would be 150x minus 120, which you notice is the same C's. Cool. Either method is totally fine. Okay. And so, whoop, except for the fact that I forgot a 0 there. I was like, that doesn't look the same. But those should be the same right there. Okay. Now with this one, it says have algebra to show that A and B are equivalent. I kind of expanded it out, but another way you could do it is you could take the GCF of this guy, factor out the GCF. And so that would be a 30, and we would be left with 5x minus 4, which if you notice is the same as the first step of the chain rule. Okay, so those guys would match there as well, okay, and they would be equivalent because of that. Okay. Nice. So again, very similar here to 11.6. We want to maybe, when we have this table here, maybe solve out the chain rule in general, and then once we've done that, then we can just plug in numbers that we want to know with, right? And so the derivative of f of g of x here is we would take the derivative of f of x times our g of x times the derivative of the inside, so times g of x. This one would be very similar, but we're just switching the g and the f, right? Times f prime of x. Right, and so that makes our life a lot easier because we're able to just plug in numbers that we need now. Okay, so this first one is f of g of negative 2. So what we're going to do is we're going to do f prime g of x. So this is going to be g of negative 2 times g prime of negative 2. Now with this, the left side, f prime of g of x, we got to kind of clean it up before we can get our final answer. We can't just plug in all different numbers here because I need to evaluate this part of it before I can evaluate the f prime. So this g of negative 2, right? So negative 2 is this row right there. So g of negative 2 there would be 3. And then minus, we know g prime, so g prime would be right there. So minus negative 7. Now, our last step is I can take f prime of 3. So f prime of 3 would equal negative 2. So this would be negative 2 plus 7, or come out to be, oh, sorry. Whoa, what am I doing? Sorry. I was still in the quotient rule mindset. Times. There we go. Sorry about that. I was totally still in the old quotient rule. Okay, so that would be a negative here. So our answer would be positive 14. Whew, that was close. Okay, so number 3 is going to be a similar idea, but this time we're going to do g. Okay, so on the second one, let's do g prime of f of negative 2 times f prime of negative 2. Okay, so g prime f of negative 2 would be what, negative 1? So negative 1. And then f prime of negative 2 would be 5. And so now we got to go back and evaluate g prime of negative 1. So here's negative 1, so g prime would be negative 9. So negative 9 times 5, so negative 45. Nice, not too bad. Okay, just a little bit of a puzzle. Here it says do not expand your answer. So it says find the derivative of each expression. We definitely don't want to expand these because you don't want to do a binomial 6 times, everything like that. That would be super crazy. Okay, and so number 4 here, I'm going to take the derivative of the outside. So that'd be 6, keep this guy exactly the same. Take 1 away from the exponent, and then times multiplying this, the derivative of this, so that would be 15x squared plus 4. And we'll stop right there. That'd be quite the problem to try to multiply out and expand like it says up there. Okay, so you don't want to expand both at the beginning or at the end there, at least for these ones. Okay. So number 5, same idea, bring this down. So 15 times 4, that would be what, 60? Keep this the same, minus 17, x to the 14th, and then derivative of the inside would be 3. So this one's not super crazy to kind of clean up a little bit, so we could at least do, say, 180, 3x minus 17 to the 14th, and that's plenty. Okay. I don't really want to see you evaluate 3x minus 7 to the 14th. Okay. Nice. Number 6, bring that negative 2 down. So that's going to be what, negative 14, 18x minus 4x squared to the negative 3. And then derivative of the inside. So 18 minus 8 x. Cool. There you go. Now number 7 here, we want to, even though, remember our first step is we want to always change that square root. So we've got x cubed plus 4x now to the 1/2. So bring that down, bring the power down, so 1/2, keep the inside the same, subtract 1 from the exponent, and take the derivative of the inside, 3x squared plus 4. Cool? Cool. All right, we're cruising. Okay, number 8, same idea, bring that power down. So that'd be 2x, 2 square root of x. I might change that actually just because, so then it makes it easier for me to see when I'm taking the derivative of the inside. Now it brings it down to a power of 1, and then the derivative of the inside, so that 1/2 comes down, so that'd be x to the negative 1/2 plus 3. Nice. All right. Okay, we've got this number 9 and 10 here. It says consider the same function. Find y prime by first expanding the inside of the radical, okay, then using the chain rule. Okay, so first what we're going to do is kind of pretend like that radical's not there and just expand it. So on the inside we've got these guys, so x to the 7th plus 6x to the 6th. Right, 6x to the 6th, and then this would be minus x, 8x to the 5th, and then this one minus 48x to the 4th. So now that got expanded out. I'm going to change this whole thing to have an exponent power. So now I can take the chain rule, right? So when I take the chain rule, I bring the power down, keep the inside exactly the way that it was, subtract 1 from the exponent, and then multiply it by the derivative of the inside. So 7x to the 6th plus 36x to the 5th minus 40x to the 4th minus 192, hopefully, x to the 3rd. And so that would be our derivative right there. Okay, definitely not super pretty, but super fun. Okay. Number 10, it says find y prime by using the chain rule and the product rule. Okay. So this one's a little bit trickier because, here, let me see if I can keep that. So if I purely just rewrite it, right, so I've got x to the 5th minus 8x cubed, x squared plus 6x. So all of this to the 1/2 power, okay? And so what it means by the chain rule is still the same thing. So we would do derivative of the outside, so the big square bracket, so we would have 1/2. Inside would stay the same, right? So yeah, either way, we can do this. We could do x to the 5th minus 8x cubed, x squared plus 6x. All of that to the negative 1/2. Okay, so that's the outside. Now the inside, we have to take the derivative of those two products, right? So now we have to use the product rule. So the product rule derivative of the first, 5x to the 4th minus 24x squared times the second, plus derivative of the second times the first, minus 8x cubed. Nice. So if you thought number 9 looked bad, check out number 10. Okay, so that is the same, would come out to be the same exact thing, even though they look very different from each other, right? Okay, so just two different methods doesn't mean one's right or wrong, just whichever one, I guess, they either ask you or whichever one you think is easier to go through. Okay, now it says write the equation of the tangent line. Okay, so we know the h and the k, we know the point, but now we just need to find the slope. Okay, it says here, note C number 8. So let's go up to number 8. And if you notice, number 8 here is the same exact equation, right? So number 8 is the same exact equation for it, and so we already found the derivative. So what we need to do, you can go through the motions again if you want, but we already know that derivative is going to be 2, holy cow, sorry. I'm looking at my notes. Yeah, so that would be good. I'm just trying to follow the derivative here. So plus 3x to the first power, and then the derivative of the inside, so this would be x to the negative 1/2. So let's change it up to make our life a little easier. So 1 over the square root of x plus 3. So now we want to evaluate it at an x of 4. So we plug in 4 for x. So 2 square root of 4 plus 3 times 4. 1 over square root of 4 plus 3. And clean it up a little bit. Okay, so this would be 2 times, so these two would be 4, right? So 2 times 2, so 4 plus 12, so 16. And this would be 1/2 plus 3, so that would equal a total of 7/2. Okay. Now the nice thing, this guy would cancel with this one, and it would leave you with a slope of 112. Okay. So that is the slope of the tangent line, but it asks for the equation. So now we can set up the equation. So y would equal 112 slope, so x minus h plus k. Ta-da! Ta-da! All right, multiple choice here. Again, sad moment. Last question of the semester of our lives together. It says, which option below shows the correct derivative of this guy? Okay, so if you notice, there's only 2 terms here, so something weird happened. So we know we're going to have to use the chain rule, right, because we've got up to the power and that kind of stuff. So let's bring it down. So we're hoping y is equal to 8 times negative 1/4 would be negative 2. And if you notice, that option is here, right? Ta-da! Yay! But unfortunately, we have to remember to take the second part of the chain rule. So we've got to multiply it by the derivative of the inside, which would be negative 6x. Okay, so be careful on that one. And now we can clean it up. This one's an easier one to clean up, so we can multiply those together. So that would give me a positive 12x, and then 17 minus 3x squared to the 7th. And check it out. There we go. D is our final answer. Cool. I hope you enjoyed it. You guys have been an awesome class, and tell a friend.